In this tutorial, we are going to talk about first principle. So how do we tend to differentiate a function using a first principle? So we need first to understand and know the formula for first principle. So now, it is something that is very simple and straightforward, and the moment you write the formula, that is a mark. Okay? For example, so the formula goes like this. F of x, which is now prime, which is dy over the x, is given by limit as h is approaching 0 of f of x plus h minus the f of x divided by h. The moment you write this formula, they are going to give you a mark. Now, it is also important for you to know the derivative. For example, I'll start with the first question. The first question is we want to differentiate x to the power 3 minus 4x. Now, using the power law, how can I differentiate this? You drop the power, so it will be 3x squared minus 4. Now, this is the answer I'm supposed to find using the first principle. So let's go ahead and try to do that. Now, what we normally do is where there is x, the first part I'm going to be pressing into x plus h. Then the second part I'm going just to be getting the original function. So let's go. So I'll bring limit as h is approaching 0. Now where there is x there, I'm going to put x plus h. But since it is raised to the power 3, I'll also put power 3. Then I'll put 4 open brackets. Where there is x, we put again x plus h. Then minus, this minus is now this one. The original function, I have to put a big bracket because this negative is going to affect everything there. So I'll put it like it is just a minute. I'm getting the differentiated one, but I'm supposed to get x squared, x to the power 3 minus 4x. That's the original one. Then I divide this by h. Now let's go ahead and also simplify that. Limit as h is approaching 0. So we have to expand this. Okay? For me here, I'm going to use binomial Pascal's triangle to get the answer first. But anyway, let me just use direct. X times x is x squared. X times h, xh. Then h times x, xh, h squared. This times again x plus h. So this will be x to the power 2 plus 2xh plus h squared. Then this now multiplied by x plus h. X times x squared, x to the power 3, that will be x squared, then h plus xh squared. Again h times that one, x squared h, then that will be 2. Now let me just shift this one this side. So x times h times x is c, x squared h. Then that one is going to give me 2x h squared. Then h and h is h to the power 3. Let's see the right terms. This guy can be added with this one. Then this one can be added with that one. So I'll have x to the power 3 plus that is going to give me 3x squared h plus 3xh squared plus h to the power 3. I'll replace this with what I have there. So we are saying our final answer, which we are going to find, is 3x squared minus 4. Let me just shift this one to be on top here. Okay, so I'll replace that one with x to the power 3 plus 3x squared h plus 3xh squared plus h to the power 3. Then I have minus. Now I can distribute. That is going to be 4x plus 4h minus, I distribute negative here, it's going to be minus x to the power 3, then plus 4x. Yeah, I divide everything by h. Let's see, I have x to the power 3 minus x to the power 3. Those two can cancel out. It's going to be 0. What else? What else do we have? What else do we have? What else do we have? I have 4x here, and this 4x can go. So now I've remained with limit as h is approaching 0. I have remained with 3x squared plus times h plus 3xh squared, then plus h to the power 3 plus 4h. Everything we divide it by h. Let's now try to factor out h on top, because if I plug in direct I'm going to get 0 over 0. But let me factor out h. So if I factor out h, I'm going to have limit as h approaches 0. I factor out h. Here I'll remain with 3x squared. Here I'm going to remain with 3xh. Then here h to the power 2 plus 4. Like that. I divide it by h. Now h and h can go. Then I have limit as h approaches 0, 3x squared plus 3xh plus h to the power 2 plus 4. Now this is, when I plug in h, it's not going to be undefined, it's going to be defined. So then I want to plug in h, I'll say equal to 3x squared plus 3x, where there is h we put 0, plus 0 squared plus 4. So this will be 0. Therefore I have 3x squared. Now this is plus, so there's somewhere here, I don't know where I left. It was supposed to be minus. Let me just go back a bit. I show you where it was supposed to be positive. I left a negative somewhere. I don't know where, but I left a negative, I know. Let me just go back a bit. Okay. I go back a bit, we see where we have left negative. That's why it's very important for us to know here, when I was distributing this negative, let me start from there. But even here, let's do this. When I was distributing this negative, this times this, it was negative 4x. But again, negative 4 times h, it was supposed to be negative here. So this was negative, meaning this was also negative. Okay? Meaning that if that is negative, then now we can factor out x. So I'll start from there. I'll factor out x. So I'll have limit as h approaches 0. So I'll have 3x. I'm factoring out h open brackets, 3x squared plus 3xh, then plus h squared minus 4. Like that. I divide it by h. Yes. So these will cancel. I have limit h is approaching 0 of 3x squared plus 3xh plus h squared minus 4. We plug in the values, it will be like that. 0 squared minus 4. So it will be 3x squared minus 4, of which that's the answer we found here. So in this case, I've used my first principle to know that the derivative of x to the power 3 minus 4x is 3x squared minus 4. Simple as that. Let us go to part 2, which is b. So we have the square root. So it's the same thing. Limit as h approaches. Now I'm going to differentiate this using the normal way, which is x raised to the power half, drop the power, keep this constant, the power reduces by 1 times the derivative what is inside. So the answer I'm supposed to find, I'll shift 1 to go on top, this one comes here, the negative has gone. So the answer I'm supposed to find is this, 2 root x, using first principle. So f of x, I'm just doing the formula. I divide this by h. So limit as h is approaching 0, what I'm going to do here is, where there is x here, I'm going to put x plus x, h. Then minus, I'm going to write the original one. I'll divide this by h. Now to get rid of the third on the numerator, I'm going to do times the conjugate. So here I'll do times x plus h plus, I'll have that. Then here I'm going to have also x plus h plus that. So if I multiply this guy by its conjugate, it's basically the same as just squaring the guy having negative. So in this case, this is the one which is having negative. I'll square that, I'll square that without me wasting time. So I'll have limit as h approaches 0, then I'm going to have x plus h minus, this is going to be x. Now here what I'm going to do now is, meaning that this one has gone, because if you want you can try it, you multiply everything here with that, it's the same as just squaring the one having negative. Then I divide that by h, then open brackets, I've got x plus h plus this. Now at this point, what I want us to know is the top part here, we can basically cancel x, because x minus x is 0. So I'll remain with h only. Limit as h approaches 0, I'm going to have h divided by h, open brackets, I'll have x plus h plus root of that. When I reach at this point, so I'm not supposed to get rid of that, because we're supposed to prove that indeed that is the answer we have found. When I reach at that point, what I'm going to do is I'm going to cancel h. Okay, I'm going to cancel h. Once I cancel h, I'm going to remain with limit as h is approaching 0 of 1 divided by, now I have root of x plus h and also root of x. At this point, I can now go ahead and plug in the value of 0. So I'll say equal to, I'll have 1 divided by the square root of x plus 0 plus the root of x. That would mean to say is 1, then root of x plus root of x, which is 1. If I add the denominator is 2 root x. So we can clearly see that what we have here is basically the same as what I have there. So it's very important for you to know first, using the normal way, the power rule, you differentiate, then you come back and use the first principle. Then you'll be able to know that maybe you have made a mistake or not, because you can differentiate this within a short period of time. Okay, so let us go ahead and also solve part D, which is the most interesting question so far. So from the question where we have been told that given that n is a positive integer, for part D, so we need to use the first principle to differentiate what we have here. But we know, guys, that using the power rule, we drop the power, you keep this constant, the power reduces by 1. So we should go ahead and find this to be the final answer, but we need to use the first principle. So the first principle states that limit as h approaches 0 of x plus h minus f of x, divide this by h. Okay, now one thing should come in our mind is that where there is x, we are going to replace x plus h. So I'll have limit as h goes to 0, and then I'm going to say x plus h, but it is raised to the power n, minus the original function is x raised to the power n. I divide this by h. But now how can I expand this? So I can expand that using binomial theorem. Okay, because we've been told that x is greater than or equal to 0. Let's just put it that way, because it's a positive integer. So hn cannot be negative, so I'm going to use binomial theorem. So there we go. What we're going to do is this. So what we have now, guys, is this. We're going to have I'm going to to expand this using binomial theorem. So how do we use binomial theorem to expand that? Let us see. So one thing we should know, guys, is if I have got n, let's have this a plus b. I'll take you back to binomial. I'm sorry. So this is going to be n, choose r, then a raised to the power n minus r, then b raised to the power r. So it keep on going. Where r starts from 0, we know that it's going to be n choose 0 until r reaches at n. So I'll put it here. R has to start from there. That will be the start. Then the last term r has to be equal to n. Why am I doing this? Let's assume that n was 4. I would have gone to n choose 0. I do, then n choose 1, n choose 2, n choose 3, n choose 4. You get it? So now what I'm trying to do now here is I'm going to expand now this. So now x is a is x, then that is that guy. Okay, so what I'm going to do, allow me to do this one. I start from this point. I'll say x plus h raised to the power n. So what are we going to have? The first one, using the same thing here, I'm going to say I'll start from n choose 0. R now is 0 because we're starting from 0 all the way to n. Then a is x. Now n minus 1. What is my b? My b is h raised to the power 0 because r is 0. Okay, now the next thing is going to be n. Okay, I'm going to say n choose 1. Okay, I'll say n choose 1. Then what I'm going to do, if n is choose 1, so I'm going to have this n choose 1, then I've got x. Now it's going to, oh, so this is supposed to be 0, sorry, n minus 0. Then this is going to be n minus 1, then h raised to the power 1 plus n choose 2, then it's going to be x n minus 2 h raised to the power 2. So this will keep on going. We don't know where it's going to end. I'm going to say it's going to end at n choose n, of which this one is going to be x raised to the power n minus n. In this case, r is n, then h raised to the power n. Now end there. Now what happens here is this. What happens, guys, here now is this. What are we going to do? Let us try to simplify this. If I have n choose 1, what is the answer here? We know that it is n factorial, then n minus 1 factorial times 1 factorial. But I'm starting with 0. Let's not confuse ourselves. So I want to start with 0. If I'm starting with 0, then it is n factorial divided by n minus 0 factorial 0 factorial. One thing you should know is that 0 factorial is 1. So we have n factorial divided by n minus 0 is just that. So that and that will cancel or remain with 1, meaning that everything here is 1. This is 1. But again here there is 1, but x to the power n minus 0 is just x. So 1 will not affect anything. I'm going to have x raised to the power n. H to the power 0 is c. N number to the power 0 is 1. I'll leave it there. Plus. I'll go to the next one. So the next one is n, choose 1, is going to be n factorial divided by n minus 1, then 1 factorial, here also factorial, of which for me to cancel factorial, the n minus 1, when I have n, same as, let me start with 5. If I have 5 factorial, it's the same as 5 times 4 times 3 times 2 times 1. So as you can see, it keep on reducing, meaning that n factorial, it will keep on reducing. N, then here is n minus 1. But since down there I've got n minus 1, I'll put factorial. So then it's going to be n minus 1 factorial divided by n minus 1 factorial. 1 factorial is 1. These will cancel. I'll remain with n. Meaning this guy now is just n. On top there I've got x raised to the power n minus 1, then h raised to the power 1. We go to the next one. So the next one is going to be the next one, guys, is 2. N, choose 2. So it is n factorial divided by n, then I'm going to have n minus 2 factorial times 2 factorial, of which this one I can also reduce. It is going to be n minus 1, n minus 2, then I end there factorial, so that it should come and cancel out with this. So these two will cancel out, and I'll end up having n minus 1, but down here 2 factorial is just 2. So I'll have n. So n I can do is same as n times divided by 2, like that. Then I say n minus 1. Then this is now x raised to the power n minus 2, h raised to the power 2. So why am I going to end there? Then I just put plus, then I end on n, choose n. Because I can clearly see that. That's why it's basically important for us to differentiate first using the normal way. I know that I'm supposed to go and end there. This guy. So once I have this, then I need to have the next one, which is going to exist where I need to have h. So that when I factor out x, h should exist here. So that when I plug in h, it's going to give me 0, meaning this one, everything will go. Let us see. So I'll say this is plus, then plus, what is n, choose n. N, choose n, is n factorial divided by n minus n factorial times n factorial. So it will be n factorial, n minus n is 0, then I'll end up having just n factorial. Everything will cancel out, I'll have 1. So again, n minus 0, n minus n on top there is going to be 0. N number to the power 0 is 1, so 1 will not affect anything, meaning this side everything has gone. I'm remaining with h to the power n. So what I have here is the one I'm going to place with the top part. I'll go ahead and say limit as h approaches 0. Where there is this, now I'm going to replace x raised to the power n plus nx raised to the power n minus 1 plus n over 2 n minus 1, then x raised to the power n minus 2 h raised to the power 2 plus, we don't know where it is ending, then plus h raised to the power n. But we have got minus here, let's not forget minus x raised to the power n. Everything we divide it by h. I'll divide everything by h. So let us see, this guy and that one can go. What have we remained with? Limit as h goes to 0 of nx raised to the power n minus 1 plus n over 2 n minus 1 x n minus 2 h squared plus, we don't know where it is ending, h to the power n divided by n. So here we forgot there was h. If I remember very well, there was h here, guys. Let's not forget. If I go back here a bit, just let me go back, I show you. I've forgotten h where there is n times x. I'm supposed to put h. Okay, here, this one. So I'm supposed to include it there. So that's why I was saying here I'm supposed to put h. So I now get rid of this. I divide it by h. So remember here there is n raised to the, or x raised to the power n, the one we cancelled. So this and that will go. Remember there is h here. So we have limit h goes to 0 so n, then I have n plus 2. I'm just copying that. I divide it by h. Now we can factor out h on top. Even without wasting time, when you factor out h, it's the same as cancelling this h because h is everywhere. Here I remain with one h. Here also one h. So I have remained with limit h goes to 0 of nx that plus n over 2 n minus 1 x. I have that. I've remained with one h plus h. So if we are to plug in the values where there is h, we put that, we have that. I have this, so that will be 0, then plus here 0. 0 times everything here will be 0. Therefore I'll end up having nx that becomes my answer, which I found there. So using first principle, just follow it step by step, it to be easy for you to remember. Okay, let's go to part E. So using the same formula, I can first differentiate that one. I know that is like that, raised to the power half. I drop the power, keep this constant, This one reduces by 1 times the derivative of the power, which is negative 2. Now when I do that, what we need to understand is that negative 2 times half is negative 1. This one is just constant. To get rid of the negative as a power, I'll shift this to go on top. So it will be negative 1 divided by 1 minus 2x raised to the power half, of which is the same as negative 1 divided by the square root of x, 1 minus 2x. Let us go ahead and use first principle to find that answer. Okay, so I'll say limit h approaches 0 of f of x plus h minus f of x divided by h. So it will be limit h approaching 0. There I'll have 1 minus, where there is 2 now, that's where I'm going to put in. Where there is x, that's where you put x plus h minus the original function. Divide that by h. So limit as h goes to 0, if I factor out, it will be like that, minus that, divided by h. I'll do the same. It's basically the same as part B, where I'm going to get the conjugate now. Okay, so I'll say this is going to be 1 minus 2x minus 2h minus 1 minus 2x. Then here 1 minus 2x minus 2h minus 1 minus 2x. So when you this is minus, sorry, the conjugate is positive. Just not forget that. So I'm multiplying this by its conjugate. It's the same as squaring the one having negative. And then you end up having limit h goes to 0. You have 1 minus 2x minus 2h. But here there is a problem. Minus, I'm supposed to put this in brackets. That bracket is going to affect everything inside there. I divide that by, now I have h, open brackets, I have this, plus root of 1 minus 2x. When I do this, the next thing I'm going to do is limit h approaches 0. Now I can open the brackets there in between. So this and this is going to give me negative 1, then plus 2x divided by h, open brackets, the square root of 1 minus 2x minus 2h plus root of 1 minus 2x. So 1 and 1 can go. This and that can go. What else? What else can we see? 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 So 2x and 2x can go. Okay. Yeah, 2x and 2x can go. And I'm going to remain with negative 2 on top. Okay. Where did we go wrong? Because initially I'm supposed to get negative 1 on top, and I can clearly see that. Okay, it's making sense. It's making sense, guys. We get rid of this, and we'll have limit as h goes to 0. I've now remained with negative 2h on top, divided by h, root of 1 minus 2x minus 2h plus the root of this. Now I can plug in, or I can cancel h. Then I have limit as h goes to 0 of negative 2 at this point. Now we can go ahead and plug in the values. We see what we're going to have. So we're going to have limit, or I want to plug in the values, so now it's just basically equal to, okay, negative 2 on top. I want to plug in the values, the root of 1 minus 2x minus 2 then times 0 plus, then it will be the root of 1 minus 2x. So that will be 0. Then I'll end up having neg 2 divided by the root of 1 minus 2x plus the root of 1 minus 2x. These two things, I'm going to add them, and I'll end up having negative 2 divided by 2 root of 1 minus 2x. So these 2 and 2 can go. On top I'll remain with negative 1 divided by root of 1 minus 2x. Using the first principle, I can clearly see that this is the same as, because that 1/2 is the same as 1 minus 2x then in the square root. So using the normal way, and that, so I prefer using the normal way first, then I go to the first principle. It's easy for me to know where I'm going. Okay, now let us go ahead and also look at how to differentiate sine x. So initially, the normal way which I want you guys to know is that the derivative of sine x is basically cos x, and the derivative of cos x is negative sine x. But here the question is, we need to use the first principle to find the derivative of sine x. That's the first part. Okay, so we'll do the same. The formula for the first principle, it is a limit as h goes to 0 of f of x plus h minus f of x divided by h. Okay, now where there is x, we are going to put x plus h for the first part, then minus the original function. So limit as h goes to 0, then it's going to be sine, where there is x is going to be x plus h, then minus sine x. We divide this by h. Now here, there are some formulas. When we go back to trig, there are some formulas which we need to know, guys, which I believe you know. If I have sine a plus b, this is going to be equal to sine a cos b plus sine a or sine b cos a, like that. But in this case now, what I want us to know is just one thing. We have, so it's more like we have now sine x plus h, meaning that is going to be, let me put it in red, that is going to be sine x cos h plus sine h cos x. So I'll replace that one with limit as h goes to 0. I'll replace that one with sine x, then cos x, or cos h, sorry. Then I put plus, I have again sine h and cos x, then minus sine x, which is this one. We divide it by h. I believe at that point you are okay. Okay, I believe at that point you are good. Now, what I'm going to do, I have got sine x. I have got sine x existing here, and also sine x here. So what I'm going to do, I'm going to rewrite this to say it is I'll write sine x, then my sine x cos h, then minus, I'll put now sine x here, then plus I have now to put this, okay, which is sine x, but it's this the same as even if I start with cos x sine h. I will write it like that. I divide it by h. Now what I'm going to do is I'm going to factor out sine for the first part. The first part here is going to be limit h goes to 0. Let's factor out sine. I'll have sine x, open brackets, then I'll remain with cos h minus 1, okay, plus this is going to be the same. Everything, I divide everything by h. Let's try to understand something. If I have x plus y divided by 2, it is basically the same as x divided by 2 plus y divided by 2. So I'm going to isolate this, okay. I'm going to isolate this in such a way that I have so limit, I'm going to distribute limit both sides, meaning I'm going to have limit as h goes to 0, I'm going to have sine x, okay. Then I'm now going to say I have times, here I have cos, or if I want I can put them in bracket to make things simple, minus that, then I divide it by h. I'll do it like that. Then plus, again I'm going to put limit because I've distributed limit now, because limit applies both sides. Then this now is going to be cos x, then sine h divided by h. Okay, so what I'm trying here is h. Now what I'm trying to do here, why have I isolated this? Because it's the one which is having h, that's why I'm dividing by h. So there are some few identities which I want you guys to be familiar with, okay, under limits. So if you come across an identity which is limit as x goes to 0 of cos x minus 1 divided by x, this is basically 0. Let me write it properly. This is 0. Then if you come across any identity which is limit as x goes to 0 of sine x, okay, divided by x, that's 1. Okay, that is 1. Now this is the identities we are going to be following here. So I can clearly see that I have got limit, okay, I have got limit as x approaches. Now a limit as x approaches this guy, we have said that that is 0. So I'm going to replace here with 0. So I have sine x, but everything here it is 0. So this times 0 plus. Again here I'll have cos, okay, x times sine h over h. Since its limit as h approaches 0, it is 1. So I end up having 1. 0 times sine is 0 plus cos x, okay, plus cos x. Like that. So if I do plus, I'll end up having cos x as my final answer. Like we said, the derivative of, so using the first principle, this is the procedure. Okay, how to differentiate sine x using the first principle. Now let us try also to solve cos x. So we are saying it's negative sine x, but let us try to see if that's the case. Okay, so we have limit as h goes to 0. Now for cos, I'll say cos x plus h minus cos x, like that. Okay, so we said the answer should be negative sign. I'll divide this by h. One thing we need to be familiar with is this. If I have got cos x plus h, expanding this, cos is bit stingy, so it's cos x cos a or cos h. Instead of plus, the opposite is the sign is the opposite. It's going to be negative. So I have now sin x cos h. So I will replace that one with, I have cos x, okay, cos h minus sin h or sin x. So this is supposed to be sine. Come on guys, this side here. So this one goes to, it's cos and sin. So even here is sin h. Sin x, then again sin h. But let's not forget that there is cos x there. We divide that by h. So as usual, here we have got cos x and also cos x. So I'll write that to say limit as h goes to 0, I'll have this. Okay, cos h, let me just get rid of this, I rewrite it. So I'll have cos x cos h minus cos x, then again minus sin x sin h. I divide this by h. I can factor out cos, limit as h goes to 0. So here I'll end up having cos x open bracket cos h minus 1 minus sin x sin h. I divide that by h. Like I said last time, if I have x plus y divided by 2, it's the same as x divided by 2 plus y divided by 2. So we're going to have limit as h approaches 0. So here now these are going to be they are going to be together. We're going to have this cos x, then this is going to be cos h minus 1. I divide it by h minus limit, okay, as h goes to 0, then we have sin x and sin h over h, like that. So like I said, one thing we need to be familiar with is the identity. So the derivative of cos is negative sign, but we're just trying to prove. So the identity which we need to be familiar with are these two. Limit as x approaches 0 of cos x minus 1 over x is 0. I can clearly see that this part here is going to be 0. Meaning, what I'm remaining with now is I'm now remaining with limit as h goes to 0. So now I'm remaining with this part here. I'm remaining with just cos x times 0, because this thing is going to give me 0. The whole of this, I'll end up having 0. That is the same as that identity. That one is 1, so this I'll replace it with 1. Then minus sine x times 1, so that is 0 minus sine x. Therefore the answer is sine x. So that is it for this one. Thank you.